Hello my friends, welcome again to my video channel. Today we will continue our work on the Drake TR7 and we will work now on the PTO, on this big unit here. We have seen the PTO has obviously a mechanical problem. Electrically it's okay. We could tune the transceiver, but the mechanical scale, the analog scale, was not working properly. And there was a sort of backslash or so, I don't know exactly. Anyhow, we will take out the PTO unit, open it and repair it. To uninstall the PTO unit, we have to remove 3 screws. 1, 2 and the third one is here. Here is no screw as I see. And I remember, no, there's no screw. And unsolder these wires. This is a RIT function as I understand. Here we have the positive supply. This is the output, high frequency output, and this is a ground connection which is connected to the chassis itself, so it can be left there. Well, first I have to unsolder the connections on the bottom side of the board. It's necessary to open this cable tie. Pinch it off carefully, okay, because some of the wires from the PTO are underneath this cable tie. Here we have the green-white, which is the output. It is soldered here. I make some short notes on the paper. The red one is this one, which is this one, which is obviously the power supply. And here's another one, brown white. This one, this is a RIT function. Okay, I make a note on the paper and then I will unsolder it. You can of course also make a photograph, and if when I have a problem I will have a look into my video to see where the wires have been soldered. Then we have to remove the knob because the PTO is slipped in the backwards direction. Oh, there's a slotted screw. Ah, here is it. Okay, here we see maybe the first problem. This rubber is always a problem, as it is brittle. Maybe this is a part of the problem, because this rubber has to squeeze the whole mechanism together to create some friction inside. It does not look like it is still doing its job. It can be replaced rather easily. There's a easy substitution, but no, this is not good. It's very brittle. It has to go. This bezel can stay in place. I will place it later, and then I remove the screws on the back side. 2 of the screws can be accessed from the bottom side rather easily. 1 and 2. And the third one we have on this side. A first check of the PTO. I connected a DC power supply, 10 volt. The output is connected to the scope. RIT is not connected, but that doesn't matter. It's not critical. The lowest frequency, when I tune it to the left side, is 49. 488, 485. The lowest should be 4955. It's 4855. Okay. Now it is in. Now we have is there a stop? There's a stop. Okay. It's indicated here, but this analog scale is set wrong. Let's go to 4955. This should be 0. The beginning, so this was what we have observed with this lever here, we can adjust it to 0. $4955. Okay. This disc should also be rotated. We are rather in the right position, not precise. And the other end should be 5455, 500 kilohertz more up. Oh, it looks good. 53, 54, 55. So that's the upper end, 500 kilohertz. 54, 55. We can go up to 5, 5, 500 kilohertz more. Okay, the setting range is okay for this PTO, but I feel it is very sticky. The old grease seems to dry out, so I have to re-grease it completely, take it apart, and then clean everything, and then re-grease and re-oil it. And now let's start to open the PTO. First thing is, we have here securing in the front. You need a proper tool. This is a small tool, but it's not critical. Now it slips off. Okay. When you do this with a screwdriver, don't do it. You will hear the famous sound, bing, and then you are down on your knees in your workshop looking for the securing. And of course, prepare some boxes to throw it in. Then the next step is to loosen this. To loosen it, you need a proper diameter. You can fix the outer plastic if it's not too hard, and then you can take off this nut. And the first scale comes, slips off. And now the second one. This one falls off, this one falls off, this one falls off. Well, and what we see here, it's not a problem, but plastic wheels should never be lubricated. It is not necessary. Plastic wheels are designed to run dry. Such a lubrication from plastic to plastic makes no sense, and even between plastic and metal, it is useless. Plastic is made of oil. Plastic is not requiring any additional grease or oil. And there's a danger. Plastic is made of oil, and maybe plastic could dwell when it gets in contact with oil. Never do this. It is not necessary to remove this plastic wheel. The securing is a little bit tight, and the small one, danger to break it, not necessary. Next step should be to remove this axis here. There is also another securing. I skipped it off with a screwdriver. It's the easiest way. It jumped off. Same topic as before. Be careful not to lose it. The securing has only a little bit more than 180 degrees coverage, so now we can take out. And this is the most critical point where we have a lot of friction. It has to be cleaned. The axis is a little bit loose. The tension of the whole mechanism can be set inside of the PTO. There's a screw inside. Important thing is that this spring is there and the spring is grounded. In some older versions of these PTOs, there's no ground connection from here to here, and this can cause frequency jumps when aligning, because sometimes the metal here, this fork, is grounded, and when it slips over the rod here, it is not grounded. But so we have a separate and a permanent grounding. That's important. Okay. And another important spring is inside here to hold this wheel under tension. You see this? You don't see it, but now you should see it. A second spring inside, here in the bottom. Okay, another topic is the ball bearing inside. As I said, it's a little bit loose, so we should now remove the cover of the PTO, loosen the screw so we can take out the balls. The shielding can be removed by opening these two clamps, squeezing them a little bit together, only a little bit. Of course the spring should be removed. Hi. Now we have it. Yes, this is the heart of the PTO. It's a permeability tuned oscillator. Let's talk about one weak point, but it is not a weak point. In many old PTOs, this solder connection here is in danger due to the movement of the coil and the rod, the core. But here we have a good construction. There's some damping in it and we have no problems. Also look for all other solder connections. The only way you can get access to this Allen screw, you need such a long hex Allen screwdriver or wrench. Feed it in. You see, and then you can imagine how it goes through this hole, and then turn it left. Use the second one. And with this method you can take out. Now we feel that the axis here gets loose. Some more turns. And still some more turns. There is a splint which prevents the whole rod to be shifted inside a little bit more, but it is sufficient. I have enough free space now to get out the balls from the bearing inside. Only use a small screwdriver and they can be taken out. One by one. Yes, the grease feels rather hard. It dried out over the decades. Okay, now it moves in the other way around because nearly all balls are out and there is no more support. It's a little bit a tricky play. There are also some more balls. Balls. We have now good access. Can clean it. Take out the old grease. Ah yes, I see the old grease now. Haha. You see this? A piece of hardened grease. I think there's more of it. That's it, what makes it sticky and so difficult to move, and it's not a joy to operate it. Here we can get access to it. It's all hardened. You see, it's all dried out. It dried out for decades. The rest I will do with some petroleum or gasoline. Fill it in. Wow. I let it soak overnight. Oh, I see what happened. What happened here? There have to be two springs inside. You see? The springs are missing. That is not good. That is not good. No. Okay. I think I have such small springs to replace it, but this is ugly because this tooth wheel has two parts, two wheels, and these wheels have to be spring loaded against each other. You see, I can move them. Well, we wait overnight, but this has to be modified, or better said, repaired, not modified, repaired. This is not okay. Here I will use some paper, a little bit stinky. I wrap it around, let it rest overnight. And the inside of the ball bearing I will clean with some Q-tips, but this I will do tomorrow. Now I clean the plastic wheels. I use a toothbrush and then clean the tooth and the interdental range area. Also this one. Here on this side. Okay. Let it dry. And then I do the same procedure here with this wheel. You can imagine what I'm doing. Same as we all do or should do every morning or every evening. By the way, I added now the cover of the PTO. Okay, and so on and so on. Takes some minutes, there's still some old grease inside. Maybe I need a little bit of more sharp instrument, for example this tweezer to get it out. Yes, I think this is a little bit better. It dried out, it hardened. I have to be careful not to break one of the teeth. This would be ugly. These residues can also be cleaned. Okay, for cleaning the ball bearing inside, we need some Q-tips, as we call it, or cotton swabs. Then we can move them around. Pick up the old grease and the residues. On the other side, it's also a work of patience. The next step is to clean this piece of rod inside. We can also use cotton swab to remove the biggest dirt, but it seems not to be so dirty as I feel. Seems rather clear. Okay. Okay. Oh, that's nice. We can use a piece of paper, clean paper. Make such a roll of it, feed it through. Should come out on the other side, yes. It is clean. Well, bring it back. Now here we can see the principle of this spring-loaded wheels. There needs to be a spring inside, and then the two wheels are squeezed a little bit together, so the spring is under tension, and then the tooth are operating against each other to prevent any play, so there is no free space between the teeth and the next teeth wheel, so it is spring loaded, and this spring is missing for whatever reason. I don't know. Can't imagine that it was done by the manufacturer. Inside we also clean the first time, but this is also rather clean. Well, next step is to clean the scale. Here we have the next problem. Grease everywhere. But here we have to be very careful because the letters may be lost when we do a mistake. I don't lay it here on this surface. I have to look for another surface to protect it. I use a cardboard, place some paper over it, folded paper, and then place the wheel on it. Then I take this Q-tip and try to wipe away the old grease. Same procedure again, cleaning the teeth. Tooth by tooth. This plastic wheel also does not need any greasing. Absolutely unnecessary. But some guys are thinking more grease helps more. But that's not true. We can wipe away. Well, on this side it is rather clean. I will use some lukewarm water, maybe some soap. I tried first with this lettering here, and the next scale, analog scale, is this one. There's also some grease in it which has to be cleaned. You see the grease gets everywhere. Oh, here's the painting on this side. I have to be careful. The grease is gone. Okay. Now I move into my other room where we have warm water and some soap, and then now we clean it. I washed it a little bit with lukewarm water. Do not rub it, only touch it. On this side here, where the digits are, if there is some dirt left and cannot be removed, leave it, forget it, because the whole scale, analog scale, is covered with a blue foil, and the blue foil covers the dirt. A lost digit is more critical. Same for the transparent one. Only touch it. There is still some dirt on it. With the back side, there is no. Okay, the dirt is on the other side. I simply forget it. I do nothing. I save it. And then, after some more cleaning, we can think about reassembling. And hopefully we manage it. All parts and components are cleaned, free from old dried out grease. Now we can reassemble the whole unit. First we start with this hose here, slip it over this With the other axis here, this is later the knob. We need some grease inside, not too much, only a little bit. I've adjusted the Allen screw so that this mechanism is a little bit loose and there are no balls inside. The next step now is to bring in the balls, but we need the securing here first. And the securing is this one. Where is it? Here is it. The securing has to secure both. And this will be squeezed. It's all easy, it snaps in. Now this whole unit is fixed. And now we can start installing the balls and the ball bearing. The whole PTO is mounted in a vertical position. The axis here is squeezed. We need some rubber protectors so this part can move freely. Now I will take ball by ball. I have added some. No, I have not added it, only on the balls. Here also some of this grease inside. I use some grease, it has graphite inside, that's the reason why it is black. I think this is a good idea to use a grease with graphite, and then we can feed in ball by ball. Very simple and stupid work. I think you can see the progress. Ball by ball, two are still missing. I have to place them, but that's the way to do it. It's a little bit critical to adjust the vertical Allen screw so that there is enough space to get the balls in, but not too much space, otherwise they will fall out. On the other side here, it's a little bit a tricky thing. You need patience, some experience, but more patience than experience. After several tries and a bottle of tranquilizer, the balls are all in. It's necessary to adjust the Allen screw with this wrench, this screwdriver, to adjust the vertical position so that the balls fit best into the ball bearing. But now, as I see, all are in and moving smoothly, and then we can continue. The Allen screw is fixed, just that the axis here rotates smoothly, but there is no play. It is fixed, but not too hard. Some drops of grease again to the ball bearing, and inside here we see a spindle where this fork here, this metal moves. It should also be greased a little bit, not too much, makes no sense, only some drops over the whole spindle, and then this part of the job is done. We add the spring. And now it turns smoothly and silky, as it should be. And now we can focus on the next topic, and the next topic is this spring-loaded toothed wheel, which had no springs. I have to look for 2 springs, which could be set in here. I have a bag with a lot of springs, and I found this one, which has the right diameter, which can be fit in here, but it's obviously too long, so I can cut it into 2 pieces. They should be sufficient for the purpose. I cut 2 pieces. I checked if they have the right length, but before I install them, I will drop some oil between these 2 tooth wheels to reduce the friction, so then it can move a little bit smoother and they are not blocked. Some drops of oil between here and here, and then we have less friction. And now we can insert the 2 springs. Only have to be careful not to lose them. They may jump anywhere. No, not okay. One is in, and we see it works. Now the other one, I think it's a good compromise between strength of the spring, which is strong enough to rotate the 2 tooth wheels against each other, but it shouldn't be too strong, because this tooth wheel here operates against the plastic wheel. So when the power of the strength is too strong on the teeth, then the plastic wheel may be damaged. So it's a compromise between strength on one side, necessary strength, and not to be too strong. Okay, now we have it as it should. Yes, it's okay. And when we install it, we will add 1 or 2 tooth turns a little bit. 1, 2, yes. So we have some force on it. A little bit grease inside. Not too much, only some drops. And then we will flip it over. And now we have to preload the difficult. Okay, now it's in. And we have here a good fixture. Yes, it rotates as it should. This is done and fixed. Now we will slip on the first analog scale. We do not know where the position 0 is in the moment. We assume it is here because the rod is rather in, so we can assume it. But this can be later aligned, it's no problem. We have the lever here, and then it can be rotated. That's it. So no need to do it in the moment perfect. We do it later. And then we need the second scale. We will adjust it later also, the 0 setting. The washer, the nut, without washer, only the nut. We should not tighten it too too hard at the moment, only by hand. And one thing is important, the securing we need. Okay, that's it. And now we have to adjust the scale, especially the kilohertz scale, not the 100 kilohertz, this one, the lower one, because there is a little bit of play between the outer and the inner rod, and we have to adjust it so that correct setting of the zero is on the top at a certain frequency. And now I have to correct myself. I told you a wrong frequency. The PTO of the 7 line starts with 5.05 and ends at 5.55, 500 kilohertz. The data I had in mind is at the 4955. That's for the C line, for the 4 line. I think 4A, 4B and 4C is the same one. This I had in mind, but this is the right frequency. This is 0, so we have to adjust now the oscillator to 5050, and this 5050 has to be in coincidence with 00 here on this scale. First we will fire up the PTO and do the adjustment. The PTO is fired up. We will set it with the center rod, which is a tuning one, to 5050. Hope you can read it. 5050. Okay, the last kilohertz does not need to be okay. The white one can be adjusted with this lever. That's not a problem, can be done later when the PTO is in the transceiver. But here we need a setting of 0, not 55 as we have. It should be 0, 0, 0. And this is a problem now. We have to loosen the nut a little bit. If I can do it now. Okay. And then the next important thing is the adjustment is done later by turning the skirt and the knob against each other, like this one. And this means that the two rods are turned against each other without changing frequency. So I have now to check to hold the frequency constant. I can use for this purpose, for demonstrations, this plier. And then I rotate the outer hose pipe, and then I will find, when I fix this one, a position where I have a lock on the left side, and I have a position where I have a lock on the right side. And now I tune this to the center of this range. It's a full rotation. So I'll make a rotation of 180 degrees, and then I will set this scale to 0. And then I will fix the scale with this nut. I just do it a little bit, not perfect. That's it. Now we still have 5050, and then I can, when I hold this frequency constant, I can rotate this scale in both directions for calibration. 10 kilohertz in this direction and 10 kilohertz in this direction. And now I will check it at the other end of the range at 555. that means 500 kilohertz up, whether we can do it in the same way. When we tune it, both rods are connected mechanically together with this rubber, and by squeezing the knob and the skirt together, the skirt has two notches which grip into the outer rod, and the knob is fixed on the inner rod. So I tune to 500 kilohertz up. It's not necessary to be absolutely precise. For example, 200, 52, 60, okay. We will see at the end whether we have sufficient tuning range here. 5550. Yes, it's possible to align it 5.3, 5.4, 5.5, 5.0. It cannot be expected that over the whole range of 500 kilohertz the scale is perfect. It will never be absolutely perfect. But when I try to go down, tuning both in parallel, with 400, it should be 5.450. It's 5.450, that's okay. The linearity 5.350, that's also okay. We cannot expect a perfect analog scale. 5.250, okay, we're a little bit off. This means the scale has to be readjusted. Then we go to 100. Should be 5.150, 5.151. Well, the scale is okay. As we have seen, it's important when setting the outer scale, the transparent scale, that it is centered this way, that we have enough overhead to align the center rod and the frequency up and down, so that the limitation is more or less symmetrical. Well, we can fasten it a little bit more. Do not over tighten it. Use your fingers carefully. That's it. And now we need a replacement for this old rubber. But this can we do only when the PTO is installed in the chassis, in the front plate, because the distance from the skirt to the front plate has to be adjusted precisely, otherwise the skirt will rub over the front plate or it is too far away. Both it's not good. So we have to install the PTO in the transceiver again. Before we bring back the PTO into this unit, we will swap the bulb. This bulb is completely black. And the other one here for the S meter also needs replacement, because I have seen it was a very weak bulb. Ah, it has 24 volt. Okay. Also has to go. 12 volt also. Both bulbs have 2 watt. I hope it's not too strong. And then we can reinstall the PTO now. We have 2 screws, and here's 1 screw. 2 and 1. And we also have to feed the wires on the bottom side. They're Now several tasks to be done in parallel. And then we can install the lamp. Next step is to solder the wires. The wires are soldered to my sketch again, so it's okay. PTO turns smoothly, scale is hopefully correct now, we will see it later in the digital display. The front panel in general needs some rework, also the blue foil here, the red foil, okay, I think it will also be removed, replaced by a new one. All knobs need some cleaning. The front is a little bit bended. Here it is not flat. Something happened. I think I will take it off, clean it. But that's not the main topic. Well, the work on the PTO is done. Now we need a replacement for this brittle rubber, which slips over here. It's there to squeeze down, or to be squeezed down, so that this skirt is fixed and the skirt comes out and squeezes against the knob, so that the skirt and the knob have a rather high friction between, and then they're moving in parallel. And only when aligning the analog VFO, then we can rotate the skirt as we have seen. But in the moment this rubber is a little bit too thick. In reality it would be softer and then could be squeezed down, but here not. So we can take this rubber as a pattern. And the replacement is such a hose. You know these hoses, they are for washing machines, dishwashers, etc. in the household. You can buy them in any hardware store or equipment for household like said. They are available. And this is a hose, 3/4 of an inch, used for washing machines and other so-called white equipment. The inner diameter is 10 millimeters. And we can cut off any length we need. I will show you how. This is a pattern. We know it's a little bit too long, a little bit smaller. I'll show you how to cut it very precisely. What do we need? We need a drilling machine with a stand. We need an aluminium rod, 10 millimeter diameter, which slips exactly into the hose. It sits firmly. We bring this aluminium rod into the machine, wrong direction, fix it, and we need a sharp knife. First we cut it into a length which is a little bit too long. We can do it like this, and then we have to look for the rotation of the machine. That's okay. And now it should slip off. Okay. And here we can see it's a little bit too long, but this side now is perfect. Now we have to cut it. Then you should move down the machine a little bit. I'm looking for the exact height. Now let's hope it fits. Back at the TR7. A little bit too short. A little bit too short. 1 millimeter or so. I have to do it again. As you see, sometimes we need several attempts, no problem. Such a hose has a length of more than 1 meter. So you have many tries. This fits, slip it over. Now with that the skirt. Okay, that's good. There are two options for the skirt, 180 degrees. It's better, or it has to be checked which is better for better coincidence of the 5 kHz ticks with the 0 setting when we align the mechanical PTO, but that's not the topic at the moment. I set on the knob now, and now it's important to squeeze it a little bit so that we have a good mechanical contact between the knob, the skirt and the rubber. As it should be. And now we can rotate the knob related to the skirt, as you see. As you see, not now, you see it, okay. And with this we can tune the 0 setting precisely. We will do it later when the TR7 is in place again. In the moment it is good enough. The topic PTO now is solved. And we can continue with this project. That's the end of part 4 about the TR7. The PTO is working now again as it should. Cleaned, aligned, relubricated. The fine tuning is done when the whole transceiver is working again. Stay healthy, stay tuned. See you on this channel.